The derivation rules for the connective disjunction are just like all the other rules for the other connectives, divided in introduction and elimination rules. The rules for disjunction introduction are fairly simple. So the difference between these two variants of the rule of disjunction introduction is simply the position. In one case, we have derived phi, and we repeat phi in the next line, and then we add any other additional formula on the right-hand side. The second variant is such that we have derived arbitrary formula psi, and we repeat it here, and then we can add any other formula, call it phi, on the left-hand side through the disjunction. So these are two variants of the same rule, and the only difference is the position of the additional formula. In short, we can say that what disjunction introduction says is that if you derive a formula, then you can always add a disjunct to it, either on the left-hand side or the right-hand side. Next, we have the rule for disjunction elimination. And this rule is quite complicated and not immediately clear, so let's go through it carefully. The rule says that if you assume a formula phi and you put it between square brackets and you label in a certain way, for example, you label it I, and then you also assume another formula psi, which is possibly a different formula, you put it between square bracket and you label it in the same way with the same number as the other assumption, and then from these two assumptions you are able to derive the same formula, sigma, let's call it sigma. Then this means that you can derive the formula sigma, so you can write sigma in the next line of the derivation, provided you have written in the previous line at the same level as with the derivation of sigma, the disjunction of phi or psi. And this allows you to cancel or discharge the two assumptions phi and psi that you've put on top, or your two independent derivations of sigma. This rule formalizes or captures the idea of a proof by cases. So note that on top here we have two assumptions, phi and psi. So you can consider this as two cases. Then at the bottom here we have the same formula sigma. And these are two separate derivations. So you should consider these as two branches of your tree, two separate derivations. Now on this side, on the side of phi, through various intermediate steps, we could derive the formula sigma. And similar, again, assuming not phi, but the formula psi right here, we could derive again through some derivation step the same formula sigma. So these are our two cases. Basically, we are in a situation in which, starting from different assumptions, we have arrived at the same conclusion sigma. And so what the rule for disjunction elimination tells us is that we can write in the next line sigma, provided that we have written here phi or psi. So these are our two cases. And then notice that this rule for disjunction elimination is indexed to the number of our assumptions, so we can cancel our two assumptions here. What the rule of disjunction elimination says essentially is that if by assuming a formula phi you can derive sigma, and by assuming another possibly different formula psi you can again derive sigma, then you can derive sigma from the disjunction of phi or psi.